So we're going to bring up next Athan. We have you on the line here. We're going to cue your team up. Why don't we put you in as co-host? We got you there. Athan, how's it going today?
Good, thank you. Sorry for the delay.
All good.
It's nice to be part of this. How should I start here? I guess I'll just kind of a brief intro. I'm founder of Boson. I've also it. There's for all physical features memory for all indigenous people and through our history, and it speaks to us if it doesn't. But it also has other.
Athan, sorry to interrupt, but we're getting really poor audio from you. Can you double check your audio preferences?
Sure. Reset the internet here. Sorry, guys. Let me see one second.
Yeah, and we'll kind of just launch in a little bit briefly with kind of our collaboration with Athan and the Boson team. A little bit of background is we came across their company and started kind of just the basic collaboration of looking at their technology, looking at their systems, and seeing where it fits in. So they're around the world kind of company. Let's do a quick mic test for you, Athan, too, while you're working on that, and we'll bring back that discussion. But their company has been working on projects around the world related to wastewater treatment, related to any kind of water quality improvements, and it has a great place here in this conversation because new technology and water purification systems are at the forefront. Let's test that back in again, Athan.
Absolutely. Can you hear me better now?
A little bit. It's a little bit robotic. I don't know if it's an internet connection, but we can.
It may be. Apologies here. Okay. Well, how well can you hear me?
Pretty good. It's kind of a little bit robotic, but maybe that's a good thing. We're talking. So Athan's bringing in some mechanical systems that discuss water purification. A little bit different than yesterday's topic, which was more plant-based modification and treatment of water. So yeah.
Yeah. So we have a both a background and understanding a little bit more about the physiochemical properties of water research over the past 25, 30 years, as well as developed a group and suite of technologies that allow us to treat water in different ways than the industry standard. And we use principles of physics, cavitation, magnetic resonance, frequency, and other different targeted methodologies of using principles of physics.
Hey, Athan, just real quick, try and see if you could get a hard connection real quick. I want to just give an intro on the video. Let me switch to the video real quick so we can share a little bit of that. Some of it speaks for itself, but I want to make sure if you can try and get, I have a direct connection and Wi-Fi, but look at that real quick, see if there's an option, or maybe just move to a different spot in the house. But let me queue up your video because I think it's really important to give everybody kind of that intro.
Absolutely. No one can hear me. Anything?
Yeah, that was a great introduction. Just starting with that. Let's do another test real quick. Let's try it without the earbuds. Sometimes my Apple buds don't work. Can we do that again real quick, Athan? Oh yeah. So I think that encapsulated an interesting part of the conversation is it's molecular, right? Again, a science-based approach to water purification. How's it going?
Can you hear me now?
Yeah.
Perfect. So is there any chop?
A little bit, you know.
Okay. So yeah, as a basis, maybe after what you were saying, I don't know if I'm still on the Wi-Fi or if I'm plugged in directly here.
Let's try it without the earbuds, maybe.
Yeah. You hear me now?
Yeah.
Same.
Same.
I apologize,
But you know what?
guys.
Let me pull it up because I think you might have some more content there. Sometimes it's hard, in just describing it. What we have right here is some of your information here, and you can kind of walk us over that too. But let me share that real quick too, because the content that you have here is really helpful too, just in visualization.
Yeah, hey guys, sorry to butt in. Athan, just try and stay as close to the mic as possible. Last time we were on a Zoom, that seemed to help quite a bit.
Can you hear me okay right now as I talk?
Much better.
Okay, awesome. Maybe in this speed, my guys are playing games and they got some sort of
Wow.
But, in principle and in effect, what we're doing is we're using principles of physics that are existing in nature that we're replicating in these different processes to disseminate elements to treat waters with these methodologies that replace the requirement. And in doing so, we're able to eliminate much of the typical infrastructure, the cost. We're also able to scale this and implement this in decentralized areas, from indigenous communities to places to help restore riverways or treat areas. We can use a lot less energy to do these things, apply these methodologies. And so our excitement with this is actually that there's ways where we, in effect, through our studies, we're able to change the evaporation temperature or the heat temperature that will normally respond in a certain process. This also has implications for us to be able to affect the latent heat evaporation of water, increasing potential more rainfall in areas that need rainfall. We can reduce the thermal requirements that's typically required in a lot of the water processes, and then actually inhibit scaling, where we usually have scaling today in a lot of the desalination processes and things like that. We can actually reduce power requirements to achieve targeted results. So it's exciting to be able to share these technologies and showcase these and be able to help do things that are impactful for the environment.
Yeah, and so we have part of our roundtable discussion that's been happening. It's been, with you, myself, your partners, Dr. Andrea Neal, who's on the call here too, and Rob Simpson, and we've kind of been going over some of this information, and maybe we can bring that up. Rob, so like your experience when you're looking over this information too, like we're really excited about the scalability, because you just mentioned that. And the scalability aspects from a unit, shipping container unit, all the way up to a massive field or array of units or a manufacturing area. So that's a really interesting part of this. And that's what kind of brought us to the table, is trying to see if there's a local scale option, a community scale option, or if there's a bigger version of that. You know, the interesting topic is doing desalination potentially for areas like Tijuana that are going to be connected to the northern Sea of Cortez. We kind of show that in some of the maps, but that is really interesting component of this. But also the wastewater treatment needs that are in the region, that becomes an aspect. And I see from your website, we'll just go back here too. Let's do a screen share. The ability to tie into agriculture production too.
Yeah. And part of that too is we've been working with agriculture both in Baja and places in Mexico for some years, and applying our technologies, both of benefits using brackish water and using a lot less fertilizers than we typically require. But also working with some of the people in Mexico to support potential legislation, because it's a very important part of getting some of the local approvals for the way people manage their water, as well as some of the indigenous groups in Mexico as well. So it's excited to help, bring all this together. And we're, like Nathan mentioned, we're working to put together and organize this feasibility study of what the most effective initial steps and projects within these are going to be, best steps forward and how we can make that happen. So
absolutely, yeah. And that makes sense. And so, just kind of overall, when we're talking about the ability to collaborate with different systems, I can see here, your water, industrial, agriculture. Let's look at the industrial real quick as just a piece of the component, because industrial water, is untreated in some places. This is to the point of, looks like nuclear energy production as a way to modify and clean that. We can probably see that from coal power plants that are, being deregulated right now, but it doesn't necessarily have to be with a technology like yours because it's fairly low cost. So that's really interesting. Just in
well, if you'd like me to share my screen, I could go through one of our presentations, and because of what you mentioned there, we do quite a few different things with power plants and stuff like that. So
sure, go ahead and do that. Yeah.
Let me open this up.
We're still having a little bit of trouble with the audio, so if you want to try and call in on your cell for the audio, that might be the best case.
Okay, let me try that.
While he's working on that, Athan and Nathan, do you mind if I reflect a little bit on my understanding of the technology?
Absolutely, yeah. That's the open forum that we're here for.
Everyone here is familiar with a human being going within an electromagnetic resonance chamber in order to get imagery of the human body. Well, think about making that chamber a little smaller in diameter, and now you're running water through it. And what this process, I believe, is thought to do is to actually change the molecular structure of the water molecule. And Athan's nodding his head, so I'll continue. And essentially, if you think about the water molecule looking something like Mickey Mouse, I believe that they're rearranging the hydrogen atoms and the bond that exists between the hydrogen and oxygen molecules in such a way that the ears are actually splayed out, making them further apart. This actually causes differentials in latent heat of evaporation, and other, the ability for, let's say, the water molecule to bond to salt molecules. It, to some extent, and I think the word that they use is disassociates the salt water molecule from the water molecule, basically reducing the strength of the molecular bond. It may have applications in both thermal, as in, let's say, multi-stage or multi-effect thermal desalinization, or reverse osmosis, making it a little easier. And see, the other thing is in creating steam is used in many industrial processes. A problem with things like geothermal desalinization or even geothermal energy is scaling. And scaling is where you get different types of conglomerates attaching themselves to the mechanisms within such systems. And this particular system seems to reduce scaling issues. I'm not quite sure how it works at hot and cold temperatures. Certainly in drip irrigation, they have lots of documentation as to reduction of scaling issues in drip irrigation systems. We're currently looking at different possibilities on how it can be applied to the desalinization process, but we want to stay within the confines of the laws of thermodynamics and conservation of energy. Need to know a little bit more about how much energy it requires to actually treat water. But there are some very promising aspects of this technology that could be used, and it's just a matter of understanding exactly what's going on with not only the water molecules, but everything else suspended within it. So I'm hoping Athan's about ready to come back on. How you doing, Athan? Oh, you're muted. Can't hear you.
He's still working on calling in. Yeah, he's working on calling in right now, but he's going to do a screen share real quick too. And I was just really, it was thought provoking. Go ahead, Athan.
So that didn't work.
It's okay. Let's just throw up your slideshow. We'll talk about it. We'll bring down the volume, and it's okay. We'll make it work.
Okay. Well, I'm gonna try like this. A lot of what Rob said is very correct. We're pretty much able to program water for targeted effects. We're able to use nuclear magnetic resonance. We're able to elongate the bond angles in the history system. In doing so, you can actually apply more energy. So, hear me or not hear me?
Some yes, some no.
Okay, interesting. So what I can try to do is, as I'll pull up my share screen here. Let's see if this works. And pull up this one here.
Whatever you're doing right now, we're getting the best audio of the session.
Great. Well, that's wonderful then. So maybe it's just identified me as a person and it's allowing me to send it up. So let's see here. If I can open this up all the way. View full screen mode. All right, let's see. Okay, so what we focus on is pretty much the ability to, I'm going to go through these a little faster here. We use resonant frequency, and we use low band frequencies, low energy applied to water. So when we're talking about how much water can be treated, it's usually depending on the size and the flow rate of the pipe, and not applied based on the amount of energy our technology needs. Water has some very interesting characteristics where it's able to communicate through the crystalline structure. Water is a crystalline lattice matrix. It's capable of carrying, transceiving, and receiving and storing weak information. But if you're able to change its structure, you're able to change the dynamics of how it transports the materials within and is able to communicate. So this has to do with heat capacity, surface tension, the evaporation, and the density of water. Able to freeze water faster than normal water after we treat it. And then we're actually able to increase its efficiency with certain hydraulic or energy based type systems, pumps, and so forth. And so here you actually see is normal structured water or usual structured water, where you have different clustering. And this relates to salt. We're able to precipitate and disseminate the elements a lot faster than you would in normal processes. And this relates directly to filtering elements before they would go to membrane systems. So we're working with a couple groups right now within these processes to get the best efficiencies for membranes and for desalination. So we can actually systemize these together for this particular project. Here's some of the reports for the melting and heating and evaporation rate differences that we've done at the University of Brno in Czech Republic. I only hear myself, so I don't know if you guys can all still hear me or not. Hello?
Yeah, we can hear you.
Okay, perfect.
I do have, can you go back 2 slides?
Yes.
Yeah, right there. Evaporative heat. Now that's latent heat of water. I believe you're looking at fresh water at 20 degrees Celsius.
Mm-hmm.
Normal evaporative or latent heat would be somewhere around the 2,200 kilojoules per kilogram. And you're looking at 1,925 plus 11. Can you provide any further information? Yeah.
I think it also, it's also relative to the particular water on site and the environment. But with this particular study, that's the differences that they were able to get. I think there's a lot more that we have to realize too with water. I think it's a lot less also just not only energy, but the dynamics of structure. And some things can't fully be measured, but there's also things that you can measure and see as absolute results. For example, when we're producing ice or we're separating elements, you'll be able to see that in a practical sense that usually supersedes often what we're doing, the effects that we're showing in some of these systems.
Thank you.
Let's see. So here's an example of the scat effector. These are systems that we can employ directly into the water mains. So what we're able to do, in effect, is, and you'll see the power supply, and it's not a system that takes a lot of energy. Same with some of these technologies I'm showing you here below. These are systems that treat water directly in line in pipes, so we don't need chemicals. This creates an effect where you're changing the structure of waters, but you're actually able to modify these structures to be more effective, not only through the processes, but to kill pathogens, to remove algae, and destabilize those molecules before they would actually conglomerate inside your water lines. And that's a big issue, because long term, when you install infrastructure, the amount of power it takes to push water through a pipe all depends on if that pipe still has the same diameter it did 3 or 4 years ago. Otherwise, you have more and more resistance or damage to pumps, things like that. And so with these systems, we're able to put them together as containerized systems. We can deploy them along riverways. Some of these systems we're using directly with buildings. So, apologize here, I don't know how to turn this off. How do I get out of? Okay. Let me see. I don't know if you guys here see me. I'm trying to get back to my main screen.
Yep, you're good.
I don't know if anyone has any questions so far.
No, I like what you have on the screen right here, a non-chemical disinfectant. So, you know, that's our current water treatment system. It'd be great if, you know, in Flint or some of these other places, you were able to install your systems right away, because, you know, the chemical is kind of our, you know, direct approach in most municipalities. It'd be great to install these at scale and a more structured scenario, you know, starting at the federal government. I'm sure you already have many of these installed here in the United States. Maybe you can talk about that a little bit.
Yes, we're doing more of mobile plants that are deployable. So I'm working with companies as well as you know, some other commercial agricultural companies. Primarily, we have projects in Mexico and in Europe. You know, what's interesting about this technology is it's pass through. You know, you can continuously flow water over these channels or through these areas, and the dynamics of what the technology provides is the way that it eliminates the biological content that would be. We can use frequency and inductance to treat anything from up to, you know, from nanometers in size up to millimeters in size. It only depends on the bandwidth and the frequency that we apply. So let me see. And that's relative also to if we're treating water that's coming in from the salton sea. In certain areas where we want to eliminate you know, algae or other things like that. Those areas where the water is going to be sitting for a while. And here's another example. This is what we were just talking about when you're talking about power plants. We were able to use frequency to elongate the hydrocarbon chain of what's it called, of fuels. So this means, for example, with CFE or a couple other large energy companies, Boson, that we've worked with, their power plants, we're able to stretch the hydrocarbon chain to get a cleaner burn, achieving between 7 to 12% fuel savings. And this is just by applying frequency and magnetic resonance stimuli that is allowing the essentially allowing the gas to have a better structure once it hits the burner and get cleaner. We're eliminating the pollution and we're saving a large amount of fuel. So the applications have also been used in hydrogen. Where we use resonance and frequency, we can actually break some bonds of water. And in doing so, we are able to produce almost 50% more energy efficiency and savings to produce hydrogen through that destabilization. And this also relates to mining technology. We're able to separate certain elements a lot better. So, for example, we can pull out more um, irons, or we can pull out certain calcium and other elements like that. Let's see, raise your hand thing here. Okay. So how we'll do this.
Let me step in real quick, Athan, too. We have Dan here. Dan, hopefully it's okay if we continue for a few more minutes. I want to try and give everybody a little bit of extra time. We had a little bit of technical difficulty with the sound. Is that okay with you, Dan, if we push back by a few minutes?
No, please continue. Yeah.
Oh, thank you.
Let's see here. Okay, so we've been applying these quite a few different ways over the years. We're modularizing them. The benefits of what we're using and what we apply is it's lower costs. Operating costs are less. We can automate a lot of the processes. We're using about 7 to 8% less of the physical area when we're talking about, depending on the size of the plant, but we're using a lot less of the normal physical area space that would be required for water plants and container reservoirs and so forth. And with this, we have a lot less maintenance that's required. You don't have the chemical components that create dangers in the work environment and in the environment. And we're killing all the pathogens without hazardous chemicals such as chlorine. So I think these are some huge benefits and the big game changer for the industry, because we're able to speed up the processes while eliminating the chemicals. And here's some examples of some of the systems within these wastewater plant processes that we use. We'll use inductance and frequency, and we modify the initial structure as it goes through different temperatures, the different processes. We're able to target the result and at the end have anything from slaughterhouse water to the raw sewage, and bring it down to something that can be reprocessed or put into the burn, used into for plants and crops and so forth.
Yeah, let me just jump in on that, because those are some of the direct site-specific conditions. We want to talk about technology as a whole, but site specificity is really important too, not only in Mexicali, but there is a cow farm on the east shore of the Salton Sea. This could be a system that could be deployed. It could be part of the New River and Alamo River too.
Yeah, absolutely. And let me see if I can. This is a really long. Well, here's a good example. As you can see, what we're doing. This is just water. There's been no chemicals applied. If you look at the heat exchangers in these pictures, you'll see that one's absolutely clean, like it's brand new, and that's not something you typically get with chemical-based technology. And at the bottom, you see the difference with the encrustments, and this would be one of the biggest concerns that we would have, because in Salton Sea, there's a lot of buildup, a lot of magnesium, a lot of different compounds that are sticky inside of pipes. Here's a couple of our different installations that we've done through the years. The benefits that these customers have seen, the different communities that we've been able to help.
Nathan, this is Roger Arnold. Can you hear me?
Yeah.
Yes, I can hear you fine.
I'm sure you're well aware. Well, let me say I've been retired for some years, but I do have background in physics and chemistry. Mm-hmm. What you're talking about, as I'm sure you're aware, flies very much in the face of conventional physics and chemistry. I'm wondering if this is something that was developed from some theoretical understanding or basis, or whether it was something that was discovered. And if you if there are technical papers that expound on the theory of how all this could be possible.
Yeah, very great question. Thank you. I appreciate that. Let me see if I can't. I'm going to go to one more page, and this one will be helpful. This was the original ones, and I'm going to move up to who started this. And this is Dr. Ella Salbania. He passed away in late 2016. He was a mentor of mine and just a great, amazing person. He studied at University of Stuttgart and in LA, and he was an Air Force pilot. Let me see if I can zoom out a little bit here so you can get a view, because this is kind of one of the original inventors of where all this started. And he's a nuclear physicist who spent majority of his life from in the Air Force to developing HARP and NORAD programs. He worked in Antarctica. He worked with some people that worked with part of the Bell Project, as well as under the wing of some ex-Germans who moved to Mexico City when he was a boy, that told him that he needed to start learning frequency, electromagnetism, and what energy might be. And it put him on a pursuit throughout his life to, through radio and through frequency, to understand a lot of the inner workings of nature. He used to keep dialogues and books of the resonant frequency of a spider mite to a table bug, developing different types of projects that were based around plants and creating example perimeters where a bird would be deterred to fly through, and he developed these systems for airports, for example. And realizing this and how these technologies were used, created systems the past 20 years of his life that could be applied this way, using the understanding of nature, using understanding the principles of physics and frequency and some of the things that we don't see, and cross-experimenting those together to get a conjugate, to get to actually figure out what the application is, the high, your low, and your middle of your X, your Y, and your Z, how to properly apply these transmissions, how to properly use these within an environment. And so we developed things from rife machines that can sterilize the soil, and kill nematodes in the soil, to creating screens that can eliminate biological contents, to actually reversing that and making contents grow more. So, everything has a polarity. Everything has the proton spin has a lot to affect of the life of a lot of, everything around us. And when we really start to understand, because this is really bigger than us, I think that a lot of conventional physics is also a deterrent. There's a difference between practical application and political science. And I think a lot of our science today is political science, and it's not backed by long-term research, long-term studies. And there's a great oversight in how we interact with our environment. Birds and bees have cryptochrome cells behind their ocular nerves. They see the geomagnetic wavelengths of our environment. They're tapped in as animal species or biological insects, things like that, to our environment in ways that we're not even looking at. Yet we're launching, thousands of satellites in the sky, not even thinking about how that RF might be affecting the biological cycle of certain species and certain elements. So to me, and thank you for the time in explaining this, is we've been able to develop these different types of technologies as different superconductors, or ways that create new dynamics within different processes that reach these targeted effects. And if you'd like to learn a little bit more, I can send you some information.
Thank you so much, Athan. And that's a great question. I mean, what we're talking about here, every particular technology and company that we've highlighted over the last couple of days, goes in the face of established politics, science, and engineering approaches. And that's what brings humanity to the next step, is when we all collectively understand that there is a better way of doing it, as long as you've tested those ideas. And what Athan is talking about is great. And I think Andrea wanted to say something real quick too. Andrea has been part of the conversation. Andrea?
Can you hear me okay?
Yeah.
Yes.
Okay. So I just wanted to say that over the last decade, there's been a number of scientific publications talking about conformation of water and utilizing different frequencies to change that conformational form. And there's even been some papers on natural occurrences of this, where they've had different phases of water that have occurred, like from deep sea thermal vents, where they've seen phases of water that look like things like water snot, is how they describe it. And so those changes and conformational changes, the trick is, how do you maintain the conformational change long enough to create the interactions that we're seeing? Because in many ways, water snaps back into its original conformational change after whatever has disrupted it changes. So it's a great question, and I think the science is evolving, and there are a lot of physicists out there working on these issues right now, and a lot of water scientists looking at both what's happening in laboratory-based standards and in what's happening in nature. But what Athan is talking about, and what they've shown and what they've done, is industrial applied. And so it's been proven not only from a desktop standpoint, but also as an industrial applied application.
Absolutely. Thank you, Andrea. Great point. Yeah, we're not an experimentation. We are, an industrial application. We're actually in the middle of bringing more capital to systemize a lot of our water plants for small communities and create these systems where we can deploy with other companies and people that want to commercialize or systemize these in communities around the world. And so we can help become that provider. And this to us, and as you look at, we've created riverways in Oaxaca and other places with great success, and wanting to do the same thing with help in Laguna Salada and Cable River and such, because it's honestly what's result of it now. So,
yeah, and that's a good point, because the next step is the Alamo, the New River, more importantly, has an important kind of next launching point where they're trying to get different technologies deployed there too. Let's hand it back over to you, Athan, quickly. If you want to do a wrap up, then we're going to switch topic real quick. But I want to encourage everybody to reach out to him. I put his website here in the chat, and we can get you in contact with Athan too. We're excited to try and deploy this at Desert Shores, if we can start testing one of the minor miniature shipping container units there, and we're kind of in the process of developing that coordination right now. Go ahead.
Absolutely. So I'm just kind of finishing up here, and relative to that, as you can see, one of the tests, I'll go back up one, was some of the projects we've done also with tomato crops and with crops in Baja, Mexico, where we've successfully able to irrigate them with water that was brackish. And in doing so, what we end up getting all the time in the results is you get more flower sites, which means that we're getting a better maximum immune disposition. And at the same time, we're getting more bricks, more sugars, and more nutrients, which means more density, more weight for the farmer, more health for the consumer. And these fruits, and usually what's comes from the benefits of this type of treated water, allows those products to stay longer on the shelf because it has a larger mineral skin thickness, or it seems to be a result of that.
Well, and more importantly, you get to use water 2, 3, 4 times, right? It becomes a component where you basically just pump it back into the system, so you can reduce energy emissions by moving water around, or recirculating, or discharging out into the ocean.
Absolutely. So that's pretty much the summary there. And I definitely invite everyone to anyone to ask any questions. And we're looking to collaborate on this and make this as effective as possible, and mission for everyone to help contribute to, the Laguna Salada and Salton Sea project.
Thank you so much, Athan. That was great. And his website's here again. You can check out the videos and feel free to reach out to us, and we can share his contact information if you have a project that you're working on that needs some of their technology. So hopefully we can deploy it at a large scale really soon. Provide some water to TJ, maybe to Imperial County. So with that, we're going to transition.
If you have one more moment, because I noticed that my partner in Mexico just jumped on, and we've been having some discussion regarding what's it called? Regarding Mexico and Laguna Salada, and maybe he can just give a couple minutes insight as maybe some of the needs and requirements, because he just came from Congress.
Okay, sure, that's okay. We'll transition quickly. Let's jump in there. You can unmute yourself real quick.
Yes. Hello, how are you?
Good. Thank you for joining us.
Sorry, with the time, it's a little bit messy. Yes, I was in the Congress past week, and start checking out how all this may work. I was telling Athan that if we want to do something with Mexico, it's needed to have the support of the Congress, because at the end, who has the budgets and who do the distribution of the money, it's always the Congress. They are in charge of the budget. So I went to the Congress and visit some congressmen, and there is a lot of interest working with the project. They want to know more. They were asking me if there is a way that you can send them a letter to present the project. They can go and, well, they will pay for the expenses, and but they can go and visit you as an official visit to our ONG. If you write a letter asking for this visit and presentation of this binational project. And I can give Athan the name of the congressman, and probably we can add some more. They are almost finishing the period of regular sessions. They are going, here in Mexico, we have the congressman, and then we have the Senate. And in I think it's 2 more months or month and a half, they will shut down the Congress, and they will go into the Union. In the Union, they mix senators and congressmen. And there is when the magic happens. So I think it's really important to try to arrange this letter, and look forward for this interview and presentation of the project.
Thank you so much, Luis. That's really, really great that you brought that up. It was your father that was the scientist that Athan mentioned earlier. Is that correct?
Yes.
Yeah.
Yes. I'm not, but I'm trying to be like one scientist.
Well, hey, you're much like me. I'm trained in architecture, and I'm getting my feet wet in earth sciences and environmental restoration. So we're part and parcel of the same thing. So we really appreciate your advocacy and going to the Congress and talking about this. And that's kind of what this whole summit is all about, is these relationships came from Athan on, I think it was Twitter or some other platform that we just communicated and connected with. And we're already starting those collaboration opportunities on both sides of the border. So we really appreciate both your time and stopping in today.
Thank you. This I think it's quite important, because this congressman that I spoke with, he is part of the issues of the north border. So he is from Tijuana. So he was really interested. Mexicali is the capital of Baja, but Tijuana is the biggest city in the state. But he was really interested, because he was telling me that actually Mexicali doesn't have issues of water right now, but they will. And the problem is that the water from TJ's comes from Mexicali. So they pump the water from the river. So obviously the problem, if this keeps going, two major cities in Mexico can disappear. So actually, it's really important for them to understand that, because he's a local first, and he wants to help his state. And I think it's really, really important to try to make this approach and try to work as fast as possible.
Absolutely. Yeah. Well, I just want to say thank you again. I agree with everything you said, and it is really about the health, life, and safety of people, right? Let alone the species of the fish and the birds, but really the people that are here can benefit in great measure. And it's one of those things that can be a template for places around the world. So thank you so much, Luis. Thank you, Athan, for joining in on that conversation. And we'll be in touch shortly. I'll give you guys a call later this afternoon or tomorrow.
Okay, thank you.
Beautiful.
Hello to everybody.